When I drag the background like this, you'll see that the background graphics disappear, and that's part of a sort of culling policy. When you're doing a very performance critical aspect, which this is, it's having to redraw every frame, it's important to have a culling policy which says, well, let's not bother to display some of the graphics. You'll also notice that when I zoom in that this background image doesn't lose quality. It's because it's purely a vector graphics, which is a very good thing. A lot of graphic systems actually change the width of your lines as you zoom in and out, and if you've got images they'll do that. So that's one very big advantage of doing it entirely in a vector graphics. Now this background, if I were to right click on the background, just say I can change the background, and it's actually looking for a DXF file. I'm not actually going to change it at the moment, but the point I'm making here is that there's an experimental DXF parser in here, which makes it's better to do that, I think, than have an image in the background, so you can drive it from your CAD system. There's another trade-off we need to look at in a graphics system, which is anti-aliasing. Now, to make it clear, let me just zoom in on a node which is what this will do. Now you see these lines here, they're pretty sharp and crisp because they're using the Windows native anti-aliasing system. But that's quite expensive in terms of performance, and so you really couldn't afford to do that when you're panning. So when you pan, the anti-aliasing has been turned off. I don't know whether you can see, if you look on you may not be able to see it in the video, but if you look closely, those diagonal lines are actually jagged when I'm panning, but when I let it go, they go sharp again. And I'm just going to show you the code for that, because again, it's in the widely reusable utilities. And it's a swing oddment, and it's an anti-alias. And there's a fair bit of code there and a fair bit of explanation, and it's always a good idea to pull that out into a subsidiary method that can be reused. So here's a method that says, look, I want anti-aliasing which is particularly optimized for an LCD monitor, and here's a method that says, well, frankly, I don't want any anti-aliasing, I want to go fast instead. I'm now going to make some arbitrary changes to things for reasons that will become clear in a minute. Let's move that waypoint, let's move that node, and let's add a node. And now let's think, oh, I wish I hadn't done that, I wish I could undo, so I'm going to press U for undo. Now that's not going to surprise you, but if you look in the middle of the screen when I do it, you'll see that there's a little alert which says how many steps of undo you've done, but it fades on its own, which is more than just a gimmick. So here we are, I'm going to press undo, and you probably saw around about here, I'll press undo again, an automatically fading alert. Now again, that's a little utility we put into the reusable library, and there's a serious point to that. As I said, it's not just a gimmick, and that is that it's one less key press. It very quickly shows you some information, but then it doesn't get in the way because it goes away again. And it's worth putting quite a few things into applications like that, because they can make a real difference to the user experience. Here's another one. If I kill the app and restart it, I do just have to resize it to fit into the thing that's capturing the video. So this doesn't look quite as slick as I had hoped it would, but the point I was trying to make is that it's completely automatically remembered where you've got to. And so the changes I've made and even the zoom levels have come back exactly as you left them. And that's because it has an automatic, most recently used document system, and I just want to talk a little bit about the code implications of that. So if a system needs to automatically save a session and then bring it back for you, it's kind of obvious that one of the things you're going to need is a way of converting your document or your model or your session into something that can be saved and then bringing it back again. And it's also pretty clear that it would be very useful if that could be abstracted so it could be reused in other projects. And to a point that's true, there's a little system in here in our reusable library called persistence for models. And it's based on a container. Computer scientists amongst you will know what a FIFO is, first in, first out. So it's a container, sort of variation on a stack. But the idea is that the very first thing you push in there is what you get back the next time you ask for something back. So if I push in an apple and then a banana and then a grapefruit, when I then ask for something back, I get the, what did I say first? Apple back. And that's very useful if you want to write software which consumes a model and works its way through it, saving away information, And then when you want to do the thing in reverse and build it back up again, you get the information back in the same order as you saved it. And that can make the code for what we call deserializing the object very much simpler, because it can be sequence dependent. So that's a special container which does that job for it, and it's got some value add as well, which is that it can convert the whole thing into one big string so that you can save it, and it can automatically manage indentation levels so that when you look at it as text, it looks a little bit like XML. Now, if this thing's going to be any use to many different systems rather than just this one, it has to have a generalization of how it talks to the outside world, and we often talk about that as a contract, and in Java the most natural way of expressing a contract is an interface. So here's the contract that things that want to use this system have to abide by. It's an interface, and it has to have a method called serialize, and it has to have a method called populate by deserializing, and it uses this container I showed you earlier, this first in first out of strings. So the next thing we need, if we're going to automatically save a session on exit and restore it when we come back in, is a way of the application needs to tell somebody that what the most recently used file path was and save the session. So in the application, under architecture second tier, we've got this most recently used session class. And I looked at this a moment ago, and to my pleasant surprise, I've realized that this shouldn't really be in the application. I can tell by looking at the imports that it has no coupling whatsoever with the application, and it could go in the utility. It's completely reusable. And you can call a method on it which says, look, this is the most recently used file path, so please set it, and you can get it, of course. Which you might think, well, there's nothing to that, it's just a setter and a getter. But the thing is, every time you do a set, it actually saves it on the disk. And it uses Java's preferences system, so that no matter what operating system you're on, as long as Java runs on it, it will magically save that information in a sensible place. So on Windows, it will be your users app data, and on Linux, actually I'm not sure where it's saved in Linux, but it will be somewhere different, and the point being you don't have to worry about it. You can just reuse this library and it will save it in the operating system's preferred place for settings. And the final piece of design we want to talk about in this section is connected with that undo and the redo, and you'll see again in our good old widely reusable utilities we have an undo package, and we've actually modeled this as something slightly different from a straightforward undo redo. We've modeled it as footsteps in the sand. And the mental model you need to adopt is that as you're editing the document, you're making a series of footprints on the beach. And at any point you can say, actually I want to backtrack, and you're walking backwards back down your footprints. And of course you can then change your mind and go forwards again. But the thing you can also do is you can backtrack so far, and then you can start making some changes again from that point, and that's kind of making a fork in your footprints. And when you do that, of course, you can never revisit, unless you've got a full tree model, the bit of path that you've cut off. Anyway, this class, which again is a reusable package, models the notion of an undo footprint trail, and you can say take a fresh step away from your existing path. You can say go backwards a step, and you can say go forwards a step. And the information you pass in is a string, so as long as your application can somehow encode its state in a string, this thing is a reusable package which can manage the entire undo-redo process for you. So in the habit I've now established, I'm going to wrap up there to avoid everything getting too long. My contact details are there. You're probably tired of me saying this by now. I hope you're still finding it useful, and I'll see you in the next section.